Hi, this is Kyle Watkins, student ID 000686163 for iTech 251 Network Management 1, and we are going to do IPv6 subnetting calculator. We're going to create one. Well, actually, I already created it, but I'm going to go through the steps with you guys that it took me to be able to complete this job. And what we will do right now is that I will show you a preview of the subnet calculator. Here I created the subnet calculator, as you can see. Okay, and well, I'll have a series of things to go through to show you guys what I did. Okay, and we'll show you the settings I put in, the formulas, right? Okay, but first of all, we're going to get into what is IPv6 subnetting. So IPv6 subnetting is an internet protocol. IPv6 is the most recent version of the internet protocol, the communication protocol that provides an identification and location systems for computers and networks and routes traffic across the internet. Okay, so IPv6 is the newer version to IPv4. It's 128 bits, and it basically, so let's look at that. We have 32 bits. 32 bits by 4 is actually 128, so it's 4 32 bits. So let's just say 4 IPv4 amount of networks versus hosts, but that's 128 bits. So we normally have it at 64 network bits network bits versus the 64 host bits, right? We also have a IPv6 has also for like a DHCP as well. As IPv6 hosts configure themselves automatically. Every interface has a self-generated link local address, and when connected to a network, conflict resolution is performed and routers provide network prefixes via router advertisements. Stateless configuration of routers can be achieved with a special router renumbering protocol. When necessary, hosts may configure additional stateful addresses via dynamic host configuration protocols version 6 or static addresses manually. Right, these are different types of IPv6 addresses. Okay, the global unicast is publicly routable. The unique local is routable in the LAN. The link local is not routable. It's only for link to link. So from this RJ45 to RJ45 or this Wi-Fi access point to that Wi-Fi access point. Access point meaning the nodes that it goes through to keep a consistent connection on Wi-Fi. Alright, so multicast addresses for groups, and anycast shared addresses. Right? Example of an IPv6 fragmentation is hextets. Each one is a hextet. We call it a hextet. It is 16 bits. So it's, as I said, it was 64. Right, what we have is the global unicast, which is publicly routable, which is basically for the network. Subnet ID, which will split up the amount of networks to host, and also give it a subnet ID so that we know exactly what subnet is on, just like our 255, and which is exactly like that, and our host interface ID. Okay, now obviously we have a subnet mask as well, but I also want to show you that when you have a consistent amount of zeros together, IPv6, you can leave it as this. This is the N. If it's in the middle, you will have to put it as a 0 alone. Okay, so just making sure you guys know that once you have a certain amount of zeros together, you concatenate them together to show that there. So for example, if it had 0001, this will be concatenated like this, and 1 will be at the end. Alright, as you can see how it looks here. Okay, this is our hexadecimal character, right, to binary conversions. Okay, the amount of decimal places. This is the decimal meaning numbers, integers. This is the characters for the hexadecimal, and the binary to match these. Okay, so basically, right, So what we're going to do right now is that we're going to get into how we created this. Alright, so I have my network to host bits here. This is what we'll always see in our IPv6 addresses, right? This whole section right here, these guys right here, this is what you'll always see in your IPv6. No, these are the amount of host versus network bits. Okay, so my bad. This here is actually what we see our IPv6 address to be. This one right here, /64, meaning that we have 64 bits here and 64 left open for our configurations. Alright, so our host bits. So these are network bits, these are the host bits. As you can see here, right? So what I did firstly is I wanted to create for that when I put in these numbers that they will automatically convert into hexadecimal here. So I put hex, so I want to convert these numbers into hexadecimal. So I put hex to decimal B12. B12 is this box here. So whatever is in B12 will automatically come from hex to decimal to tell me how much. Okay, and what I did is that I copied it, I used this and I copied it all the way across here until all converted to their own hex to dec. For example, this is a C12, D12, and etc. Right? And then what we did as well is that we wanted to create a binary value. Right? We also want to create a binary value for whatever these were. So after this was converted into this, we want to find a binary value for this. Okay, it's just like you only 194 or whatever it is, so that you will have a binary, the numbers for it, so you will know exactly what it is. And what we did here is that we said base brackets B11/2, which is for the base 2, and 16 is for the 16 bits length, right? This is what we did here. So base equals base B11, which is B11, take this, and we want to find the base of it in bottom up, right? So we can get the binary from those numbers, to turn those numbers into binary. Okay, but as you can see, right, as you can see, to tell you how this works, it's so funny. You can see that we turn the binary, we turn the hex, right? When we use this, we turn the hex into decimals, and then we use the decimals, the base of the decimals, to find out what it is. Okay, so we can get 16 bits in the base of decimals. Alright, so what we will know is that at the end of the day, alright, so let's just, for example here, 2 0 0 0 1 0, and then 0 0 0 0 0 0 0, right, and 1 0 0 0 1. So as you can see, once we use our calculator, how we use our calculator is that we're trying to match up that we get all the characters to fit. So for example, ODB8, right? We have O, which is here, D, 1101, as we have here, B, 1011, as we have here, 1011, and we have 8, which is 1000. Okay, so that's how we line up the 16 bits, guys. Obviously 16 bits, 16 characters. Okay, guys, and we got all this from basically converting this into this. Alright, so let's go furthermore. Right, so that's how we did our first conversions, right, from hex to decimal, and then we did a base on the decimal to get the binary. Alright, convert the host. So next thing we're going to do is, convert the host to hexadecimal and show network prefix. So what we did here now is that I wanted to convert these hexadecimal here. So get the network. We want to do a network prefix. So this is the network prefix right here. This is also the same thing here, but always it's almost similar here, right? We have our binary here, which is FFFF, because F is all ones, all right? And what we basically did is that we did the same thing. We got the same formula. So we actually convert whatever it is inside here in B26 to here to get our binary. And then what we did is the same thing here. We went to our to get our binary, to create our from our decimal to our hexadecimal, and then we're going to get our decimal to binary, which is this. As you can see, I use base B25 again, base to the power 2, no, not power 2, but base to the 2, and 16 bits, which we have here 16 bits. Okay, and now we're going to do something called ANDing. So to use the ANDing on the decimal of IPv6 host prefix, and then the decimal of the IPv6 network prefix. Alright, as you can see, I also have this is for the ANDing. Right, we have our exactly what happens to our for up here E19. What we're going to do for E19, let's see what's E19. Okay, this is converting the decimal to hex. Hi. I've also set concatenation so that these could show up all these here in one, and these here in one cool layout for you guys. Okay, what we're going to do here now, we're going to test this. So we're going to test the fact we've changed to be 0. Let's change it to 0 if this will change here as well. So right, so as you can see, we have everything changed across. So as you can see here, we could change now. Let's change this to 0, right? As you can see, the amount of hosts changed, and we have a change here as well. Let's change the network prefix now. Let's just change this now to a 0. Let's see if this will change as well. As we can see, it changed. Okay, so now we have our subnet calculator created. Everything is working fine. As you can see, all our addresses has changed as well. Okay, and we have all our configurations inside to make it function. Remember, to get these things, you have to use a base of the decimal and the 16. Don't forget the 16. Right, so we want to get this cell B11, right? So we count this decimal from B11 to the base 2 and 16 bits, and in order to get that. Okay, alright, so that concludes our IPv6 subnet calculator. I hope you also understand IPv6, right? So thank you very much for listening to my tutorial. Okay, this will actually be 60/60. Right now then, as it is stands right now, /60/60 for the setting is that right now for this one here, FFF0. That's a /60. Okay, network prefix. Okay guys, so thank you very much for listening to my tutorial on IPv6 subnetting.